Hello everyone. Very good morning. Let me know that sound quality, picture quality, everything is fine. Yes, please. Everyone join session now. And inform me that how many students are new here. Yaswant. Sawan. Okay, what is your branch, Yaswant? And Sawan, what is your branch? So everyone, very good morning. This is Sanjay Rathi. And that is a first class of very important subject, that is analog. Okay, so Nandesh, Krishna, Somnath, Harshita, very good morning. Good morning, Rakesh. Now, so this is an analog, and as you know, this subject is important for all competitive exams, whether it is ISRO, GATE, engineering services, any technical exam, assistant engineer, junior engineer, and so on. And that is very important for what? VLSI, very large scale integration. और जहां भी आप इंटरव्यू देंगे, इन एवरी इंटरव्यू देयर विल बी क्वेश्चन फ्रॉम व्हाट? एनालॉग. अगर आप अपना VLSI में करियर बनाना चाहते हैं, देन डेफिनेटली यू हैव टू गेट द कमांड ओवर दिस पर्टिकुलर subject, guys. Okay, so you can watch this schedule. This is the first class of analog, and what is written here? Operational amplifier. Yes, I will give you the reason why I'm going to start with the operational amplifier and how we are going to get the command over this particular सब्जेक्ट. ओके, बस मैं एक ही रिक्वेस्ट करूंगा, जितने भी स्टूडेंट्स न्यू हैं वो थोड़ा सा ईडीसी का पार्ट कर लीजिए. विच पार्ट ऑफ ईडीसी? ऑलरेडी डायोड डन. देन व्हाट? बीजेटी. तो प्लीज ट्राई टू अटेंड दोज क्लासेस ऑन द डायोड्स. 10 to 12 lectures, PN junction, then semiconductor physics, basics of the BJT. Already we have started the BJT, and some part of network, basics of the network, KCL, KVL, and mesh analysis, nodal analysis, Thevenin's. So you are going to get the command over this subject. Okay, तो चलिए स्टार्ट करते हैं. डोंट वरी अबाउट दिस. पहली क्लास है, कोई प्रॉब्लम नहीं है. फर्स्ट क्लास में भी हम लोग एकदम धमाकेदार एंट्री करेंगे. Okay, then this is analog electronics operational amplifier part 1. सब आ गए? कितने हैं ऐसे जो नए हैं? आज फर्स्ट क्लास है भाई जिनकी. हाउ मेनी स्टूडेंट्स आर न्यू हियर? मतलब फर्स्ट क्लास मतलब ऐसा नहीं कि एनालॉग की फर्स्ट क्लास, जस्ट दे हैव ज्वाइंड दिस गिग्स फॉर गेट एग्जामिनेशन एंड इसरो एग्जामिनेशन. कोई है ऐसा नया? और ऐसा कौन है जो मुझे नहीं जानता? मतलब थोड़ा होता है ना, पहले से आप जानते हो, थोड़ा सा फीडबैक है तो आप पॉजिटिव लेते हो, और नहीं पता है तो पता नहीं कौन आ गया पढ़ाने के लिए. टेल मी. ओके, तो चलिए स्टार्ट करें. वेरी गुड मॉर्निंग सर, माय फर्स्ट लाइव क्लास कंप्लीटेड टुमारो. ओके, recorded. Okay, Nadeem, you have network. Okay, network recorded now. You have completed the basics of the network. So yes, now start with this subject, no problem, but at the same time you can start what just get the basic idea about the semiconductor. No need to enter into the depth of that. And then basic idea about PN junction, then BJT. So we will learn more about the diodes, BJT and MOSFET here, applications of the diode, BJT and so on. So guys, everyone again, very good morning. This is Sanjay Rathi. Now that is my introduction, guys. I am an ex-IAS officer. Okay, and I am having around 24 years of teaching experience. Okay, in the field of competitive exams, especially for GATE, engineering services, ISRO, DRDO, BARC. पहले ये सब एग्जाम इंडिविजुअल होते थे, बाद में इसको क्लब कर दिया गया विद गेट एग्जामिनेशन। और आज भी जैसे इसरो का एग्जाम, समटाइम्स डीआरडीओ, समटाइम्स बार्क, कुछ एग्जाम्स अपने अलग से भी कंडक्ट होते हैं और बाकी सब गेट एग्जाम के थ्रू आपको पीएसयूज में कॉल आती है। एंड दैट्स व्हाई दिस आर द वेरी वेरी इंपॉर्टेंट वन। ओके, तो ये मेरा एक्सपीरियंस है 24 years. Meanwhile, I have qualified and selected for what engineering services exam that is conducted by UPSC multiple times. ओके, शाहजहां रोड में यूपीएससी में मैंने इंटरव्यू दिया है और इंटरव्यू पे काफी नंबर आए हैं। दीज आर माई रैंक्स: AIR 16 in ECE 2005, AIR 21 in ECE 2008, एंड थ्रू ऑफलाइन क्लासेस जिसकी आप बुक पढ़ते हैं, मेडिजी वगैरह की बुक पढ़ते हो आप लोग, यस और नो? अभी ये जरूरत नहीं है, अब सब ऑल द पीडीएफ्स आर अवेलेबल एंड सो ऑन, तो जरूरत नहीं है, अब सब यहाँ पे हो जाएगा, हम लोग गाइड करेंगे आपको। तो वहां हम लोगों ने काफी पढ़ाया है और बहुत अवेयरनेस फैलाई लोगों को, जबरदस्त अवेयरनेस की व्हाट इज द इंजीनियरिंग सर्विसेज, गेट एंड सो ऑन। उसी का रिजल्ट है कि अभी आप लोग पढ़ रहे हैं। तो ये था, आई हैव ट्रेन्ड मोर देन 1 लाख स्टूडेंट्स फॉर वेरियस कॉम्पिटिटिव एग्जाम्स। नंबर ऑफ स्टूडेंट्स गॉट फर्स्ट रैंक इन वेरियस कॉम्पिटिटिव एग्जाम्स, फर्स्ट रैंक, सेकंड रैंक, अंडर 10, अंडर 100। यस, ये पॉसिबल है। फॉलो द इंस्ट्रक्शंस ओनली। कोई ऐसा आप ऐसे शख्स से नहीं मिल रहे हो जिसका एक्सपीरियंस नहीं है। और दीज आर माई एरियाज, बहुत सारे सब्जेक्ट्स में पढ़ाता हूँ। अगर आप मेरा चैनल ज्वाइन करना चाहते हैं तो यू कैन स्कैन दिस संजय राठी GFG, स्कैन दैट, और आप GFG गेट ECE EE का एक कॉमन है, वहाँ ज्वाइन कर सकते हैं, जहाँ पे अभी हम लोग और भी बहुत सारी चीज करने वाली हैं, क्वेश्चंस प्रैक्टिस, डाउट क्लियरिंग सेशंस एंड सो ऑन वहाँ, ठीक है। तो क्या हुआ अनमोल, पियासा पॉल? ओके सर, ये नेटवर्क का क्लासेस कहाँ मिलेगा? मुझे ऐप में भी कहीं दिखा नहीं। नेहा, यू आर नॉट एबल टू फाइंड दैट नेटवर्क क्लासेस?
यस सर।
ओके, आई विल आस्क देम, क्योंकि आप शायद, आई थिंक यू एलिजिबल तो हो गए, या फिर ऐसा तो नहीं है जहां से एडमिशन लिया है आगे हो गए? नदीम?
Sir, I'm from the GATE course. Is that why I can't find the network classes?
Okay, you have joined for GATE courses, na?
Yes, sir.
Okay, no problem. I will ask them how you can watch that. मैं उनसे पूछता हूँ एक बार
Okay, sir.
कैसे पॉसिबल है।
यहाँ से लेक्चर मिला है, उसी के नीचे मिल सकता है।
हाँ, नदीम ने तो ज्वाइन किया अभी, मैंने खुद ही ऐप नहीं देखा, एज अ स्टूडेंट मुझे भी लॉग इन करना होगा लग रहा है। ठीक है नेहा, आफ्टर क्लास आई विल आस्क देम एंड पूरा इन्फॉर्म करता हूँ मैं आपको। स्टार्टिंग में मुझे भी नेटवर्क नहीं मिला था, देन चंदन सर से बात करके मिला। ओके ओके नदीम। नेहा, मैं बात करके आपको, हो सकता है कि आपने जिस डेट से ज्वाइन किया ना वहां से आपको अवेलेबिलिटी है, आपको बैक साइड से ज्वाइन करवा देंगे। ओके
सर,
हाँ, न्यू चैनल है, आप अब जो सब्सक्राइब कर लेना नया चैनल, मैं तो रोज आपको लिंक भेज रहा हूँ यूट्यूब पर। चलिए आ जाए, अब स्टार्ट करें। दैट इज माई इंट्रोडक्शन गाइज, हो गया इंट्रोडक्शन का भी काम। अब जितने नए स्टूडेंट है वो जान जाएंगे, पहले आप रेगुलर करो। इफ इट इज योर फर्स्ट क्लास, मिनिमम ट्राई टू अटेंड व्हाट 5 to 7 क्लासेस, देन यू विल गेट द आइडिया। ओके, अब आते हैं फर्स्ट ऑफ ऑल थोड़ा गेट का सिलेबस, फिर मैं अपने हिसाब से बताऊंगा। देखो, इन इलेक्ट्रॉनिक्स इंजीनियरिंग अभी जो भी आपका सिलेबस आया है वो तो है ही है, सिलेबस में कोई खास चेंज नहीं हुआ है। दिस ईयर गेट इज कंडक्टेड बाय व्हाट? IIT गुवाहाटी, IIT गुवाहाटी CSE 7. This is the subject for your branch is computer science. Your branch is computer science. No. This is for what? Electronics and electrical and instrumentation branch. Not for CSE. Digital is for CSE. Digital, maths and aptitude. That is common. And if you want to make your career in what VLSI, then it is subject for you. और सेमेस्टर में है अगर तो आप यूज कर सकते हो, आपके सेमेस्टर एग्जाम में है ये, गेट में नहीं है भाई, गेट में नहीं है सब्जेक्ट। ओके, नाउ देखो, एनालॉग सर्किट मींस फर्स्ट ऑफ ऑल द डायोड सर्किट्स। डायोड मींस three important topics. First one is the rectifier, then clipper, and then what? Clamper circuit. Only the three topics are mentioned here: rectifier, clipper, and what? Clamper. Then second topic is what? BJT and MOSFET amplifiers. BJT and MOSFET amplifier, biasing, AC coupling, small signal analysis, frequency response, current mirror circuits, differential amplifiers. Okay, then guys, operational amplifier circuit, various applications of the operational amplifier, summer, differentiator, integrator, active filter, symmetric trigger, and what oscillators. Operational amplifier, that is mentioned in the syllabus in electronics. Similarly, this is the in electronics. I will explain why I am going to start with the operational amplifier. Right, ISRO is this, sir, is the subject for ISRO. Oh, sorry, I have to check that. HN, I have to check that. है आपके हिसाब से आप बोल रहे हो? This is for CSE. I think होगा यार, ISRO में जरूरत पड़ सकती है. सॉरी, थोड़ा सा मैंने सिलेबस में कंफ्यूज हो गया, मेरे को आई हैव टू चेक. कुछ क्वेश्चंस तो आते हैं क्योंकि प्रीवियस ईयर क्वेश्चन पेपर से ही समझ आएगा आपको. HN, तो अटेंड करो पहली क्लास, डोंट मिस द क्लास, यू विल गेट द आइडिया अबाउट द बेसिक्स ऑपरेशनल एम्पलीफायर. ओके, देन फिर बात करते हैं. नाउ electronics engineering, these are the important topics. First is the diode circuit, second is the amplifier by using BJT and MOSFET, and third is the operational amplifier circuit. Then second is the electrical engineering, again that is written simple diode circuit, clipper, clamper, rectifiers. Amplifiers, same syllabus, biasing and equivalent circuit, and the frequency response. Oscillators and feedback amplifier is mentioned here. In electronics, the feedback amplifier is not mentioned, but here it is a feedback amplifier. Operational amplifier, characteristics and applications, single stage active filters. Active filters like 𝐂𝐤𝐿𝐴, Butterworth, and voltage controlled oscillators and what timers. That is in the syllabus of what? This one. Official GATE syllabus for electrical engineering. Now, this time IIT Guwahati will conduct a electrical exam. Okay then, GATE examination. अब आते हैं, what are the weightage of that? If when we are talking about the electrical branch, right, analog electronics for electrical branch, watch this. Analog electronics for electrical branch, we will get your 2 to 6 questions. 2 to 6 questions. It may be of 1 marks, it may be of 2 marks. I'm giving you the average value. So marks is what? 2 to 10 marks. But electrical, how many students from electrical branch? Anyone from electrical branch? So 2 to 10 marks, and 10 marks out of 100, huge weightage, right? And it is a reliable subject for electrical branch. You can solve all the questions from the analog. Okay, electrical में तो आप सब solve कर लोगे, इतना अच्छे से मैं पढ़ाऊंगा कि आपसे सब solve होगा यहाँ पर. This is a reliable subject. These are the important topics, guys. These are the important topics. Okay, but remember the complete syllabus is important. Then दूसरा है electronics branch, we are getting around 6 to 10 questions. Marks is what? 9 to 15, minimum 9 marks, maximum 15 marks. My dear friends, this is one of the most important subject, core subject for electronics branch. Right, in every interview there will be question from this topic. So you have to get the command over this, extraordinary command over this subject. These are the frequently asked questions from 2019 to 2025, last 6-year trend. Okay, then this is the electronic. These are the weightage of what? Analog electronics, I'm giving you the idea about that. ISRO, again this is a very, very important one for, right, ISRO, this topic is again important. Then books, you can follow what one book that is called Millman-Helkias, that is the integrated electronics. For just remember the subject, you can follow for what? BJT, you can follow for clipper, clamper, rectifier. Some questions from operational amplifier also, feedback amplifier, oscillators, sinusoidal oscillators. Right, now this book, Cedra and Smith, this book in a GATE examination, this book is very, very important. Number of questions from that book. Operational amplifier, for example, MOSFET, right, or what some questions on clipper, clamper, rectifiers, BJT, and so on. So this book is important, as well as this book is important. 2 books. Right, you can also follow number of textbook, Boylsted, right, or I am having around 25 books on analog, minimum 25 books on analog. तो इतना ज़्यादा नहीं पढ़ना है, फॉलो द नोट्स, पूरा नोट्स पे ट्रस्ट करो आप, इतनी ज़रूरत नहीं है बुक्स की, ये बुक रख सकते हो, वो बुक रख सकते हो, दोनों मिलमैन, हेल्कियास एंड सेड्रैन स्मिथ। ये तो हो गया भाई सिलेबस। अब मैं अपने हिसाब से सिलेबस बताता हूँ, लेकिन उससे पहले आप बताइए फिर से अगेन, सब जितने भी न्यू स्टूडेंट्स है भाई, वो चाहे मॉर्निंग में क्लास हो, चाहे इवनिंग में क्लास हो, चाहे जब हो, टेबल चेयर पे बैठना है। हाउ मेनी स्टूडेंट्स ऑन टेबल चेयर? एवरीवन टेल मी। कहाँ बैठे हो? पलंग वलंग पे तो बैठ गए हो, बेड पे बैठे, या झूले में हो, या गार्डन में हो, कहाँ हो आप लोग? बताइए जरा। ऑल आर ऑन टेबल चेयर? यस, बिल्कुल अलर्ट होकर बैठिएगा, राइट, दिस इज कंपल्सरी। सेकेंड थिंग, पेन, नोटबुक एंड कैलकुलेटर, पेन, notebook and calculator, that is important. Then hold chat while attending the class and try to maintain the regularity and punctuality. Okay. और अब भी अगर कोई क्विजेस स्टार्ट होते हैं तो डेली ट्राई टू गिव द ऑल द क्विजेस गाइस। नाउ अब आते हैं, मैं अपने हिसाब से सिलेबस को मेंशन करता हूँ। अब देखिए जरा सिलेबस कैसे है, ट्राई टू अंडरस्टैंड दिस वन ऑफ द मोस्ट इंपॉर्टेंट थिंग, हाउ वी आर गोइंग टू कवर द कंप्लीट सिलेबस ऑफ एनालॉग। Now, first of all, remember, first is what in according to the syllabus, that is the diode circuits. Diode circuits. In the diode circuit, we have the rectifiers and filters. These are not the low pass, high pass, band pass filter. This is the filters used with the rectifiers. Okay, we want to convert the AC signal into what? DC. So we are using the rectifiers. So this is the first diode circuit. Then second diode circuit is clipper. Third diode circuit is clamper. Fourth diode circuit is voltage doubler. Right. Here, with the help of clipper and clamper, you will get the idea about the peak detector also. Peak detector. Okay, so basically these are the important diode circuits. Okay, rectifier and filter, clipper, clamper, voltage doubler, peak detector. We are getting number of questions on these topics. So I'm going to take around 15 to 20 hours for that. This is the diode circuit. Okay, this will take around 15 to 20 hours. Then second topic is, right, once it is covered, then BJT. Biasing and about first of all basics of the BJT. Then biasing and stabilization of BJT. Stabilization of BJT. Okay, now try to understand. Once you will get the idea about the basics of the BJT, then we can start what? Voltage regulator. Voltage regulators. This is the applications of what? Zener diode. So you can say, sir, it is a diode circuit, so why we are not covering here with this topic, rectifier, clipper, clamper, voltage doubler, peak detector, then voltage regulator? No. When we are designing the voltage regulator, we have to use what? Operational amplifier, we have to use the BJT. So first of all, we will get the idea about the BJT, then we will learn about the voltage regulator. पूरा BJT का use होगा. तो ये this is the voltage regulator. So first get the idea about the BJT, then voltage regulator by using Zener diode, by using BJT. Then after that, now to biasing and stabilization of BJT, then voltage regulator, then there is one circuit, current mirror circuit. Current mirror circuits. Again, this is important topic, current mirror circuit. After that, then amplifiers. So what is the meaning of the amplifiers? First of all, you will get the basic idea about the amplifiers. What is the amplification, why it is needed, and so on. Amplifiers. Okay, different types of amplifiers, you will get the idea. Then frequency analysis of what BJT, that is called frequency response, or this is called low and high frequency analysis of what BJT. So first of all, we will learn about the low frequency analysis of BJT. Okay, then a high frequency analysis of BJT. These are the two important chapters. ये पूरी analysis है what about the amplifiers. If we are giving the low frequency signal, what will happen? If we are giving the mid frequency analysis, and if we are giving the high frequency signal, then what is the effect and so on. पूरा यहाँ पर आएगा basics of the amplifiers as well as high and low frequency. Or here we are going to use what? Here we are going to use models, that is called small signal models, hybrid model, pi model, RE model. So we'll learn more about this. So ये तो first है पूरा diode circuits, then what basics of the BJT, biasing and stabilization, then what voltage regulator, current mirror, amplifiers, and so on. Once you will get the idea about the low frequency and high frequency analysis, small signal model, everything, then next topic is biasing and stabilization of FET. Biasing and stabilization of FET. FET means here we are talking about the MOSFET, right? Because JFET is not in the syllabus of GATE exam, but it is in the syllabus of what? Engineering services as well as ISRO examination. So I will take 1 or 2 sessions on JFET also, that is junction field effect transistor. But remember, if you are GATE aspirants, you will get question on MOSFET only, metal oxide semiconductor field effect transistor. No question on JFET. So biasing and stabilization of FET, then a low and high frequency analysis. Low and high frequency analysis of FET. Then again here you will we will discuss current mirror circuit. तो आप बोलेंगे this is the already mentioned current mirror circuit by using FET. This is the current mirror circuit by using the BJT. This is the current mirror circuit by using BJT, then current mirror circuit by using FET. Okay, now FET over. Then guys, feedback amplifier, oscillator, multi-stage amplifier. We have the different topics, guys. Then after that, feedback amplifier, negative feedback, positive feedback, what are the advantages of the negative feedback, different types of topology, voltage series, voltage shunt, current series, current shunt. Here we will learn about that. Now feedback amplifier, after that oscillators. Oscillators means this is the sinusoidal signal. How we can generate the sinusoidal signal? There are different types of oscillator, like what? RC phase shift oscillator, Wien bridge oscillator, कॉलपिट, हार्टले ऑसिलेटर, क्रिस्टल ऑसिलेटर. क्या आपने नाम सुना है? कितने लोगों ने सब नाम सुना है भाई? बता दो. हार्टले, कॉलपिट सुना है ना? RC phase shift, Wien bridge oscillator, and so on. So here you will learn about the Barr-Gaussian criteria. वो criteria क्या है? How we are going to design the oscillators? What are the conditions for the oscillation? What is the frequency of oscillation? Everything here. And after that, one topic, that is what? Multi-stage amplifier. Multi-stage amplifiers. Multi-staging means we are connecting the number of stages. For example, single transistor, then again second transistor, then third transistor. In this chapter, you will learn why we are doing the multi-staging. What is the basic purpose of the multi-staging? Okay, so RC coupled amplifier, 2 stages, 3 stages, and so on. You will learn detail about this. What is the effect of the multi-staging on the frequency? So this topic is very important. You will get the idea about the cascade amplifier, Darlington pair. Okay. Then after that, here one topic is what direct coupled amplifier. Direct coupled amplifier. Then tuned amplifier. Direct coupled, then emitter coupled amplifier. Right? Emitter coupled differential amplifier. Emitter coupled differential ECDA. This is called emitter coupled differential amplifier ECDA. Okay. Here again there is a very small topic but important one, tuned amplifier. Tuned amplifier. So direct coupled amplifier, emitter coupled amplifier, tuned amplifier. After covering all these topics, try to understand. After covering the diode circuits, then basics of the BJT, then what voltage regulator, current mirror circuit, amplifiers, basics of the amplifiers, low and high frequency analysis of the BJT, models, small signal models, then biasing and stabilization of FET, then again low and high frequency analysis of FET, current mirror, feedback amplifier, oscillators, multi-stage. At the end, you will learn about what? Operational amplifier. Now guys, watch this. After that, operational amplifier. Now, number of applications of the operational amplifier, inverting amplifier, non-inverting amplifier, non-inverting amplifier, differential amplifier, differential amplifier, inverting summer, non-inverting summers, voltage to current converter or current to voltage converter, converters, right? Integrator, differentiator, integrator, differentiator, ओके लॉगरिथमिक एम्पलीफायर, एंटी लॉगरिथमिक एम्पलीफायर, ये सब आएंगे, लॉगरिथमिक एंड एंटी लॉग, एंटी लॉगरिथमिक एम्पलीफायर्स. Guys, these all are the amplifier. Just go through the syllabus, you will get the idea, then we will cover all this. These are the operational amplifier: inverting, non-inverting, differential, summer, voltage to current, current to voltage, integrator, differentiator, log, anti-log. And some important circuits are also filters, like active filters, all active filters, low pass, high pass, band pass, band reject, all pass, low pass, high pass, band reject, all pass filters, active filters. Then all type of oscillators or generator, like square wave generator, triangular wave generator. Here we will deal with what? Sinusoidal oscillator. Sinusoidal means this type of signal. But if you want to join, if you want to generate what is square wave, triangular wave, right? Then again we are using the operational amplifier. So here you will design bistable, monostable, or stable circuit, or stable multi-vibrators, square wave generator, square wave generator, triangular wave generator, triangular wave generator. Or here you will learn about what? Schmitt trigger circuit, Schmitt trigger circuit, most important topics. This is about the operational amplifier. Just I have written all the important topics, but I am going to cover each and everything about what operational amplifier. Okay. So this is the last topic according to your syllabus. Yes, this is the last topic according to your syllabus, everyone. Okay. But in my class, I am going to start with the operational amplifier. दिस इज माय फर्स्ट टॉपिक। व्हाई सर, ऐसा क्यों? सिलेबस में तो लास्ट में मेंशन है, आप पहले क्यों स्टार्ट कर रहे हैं? देखो मैं आपको बताता हूँ। दिस इज द क्लास फॉर नॉट फॉर व्हाट सेमेस्टर एग्जामिनेशन। ये सेमेस्टर एग्जाम के लिए नहीं है कि आप सेमेस्टर देने वाले हो, सर सीक्वेंस में पढ़ेंगे, पहले ये पढ़ेंगे फिर वो पढ़ेंगे एंड सो ऑन। दिस इज द क्लास फॉर व्हाट कॉम्पिटिटिव एग्जाम्स, गेट 2026। यस, सब 2026 पे फोकस कर रहे हो ना? बताओ कोई आगे भी है क्या? 27 वाला, 27, 28, 27, 28 कोई है? तो all are focusing on what? GATE 2026. So we have limited time. Second thing, everyone know the idea about the operational amplifier, BJT, diodes and so on, but I will give you the complete idea about this. तो देखो यहाँ पर होता है डायोड सर्किट, रेक्टिफायर एंड फिल्टर्स, क्लीपर, क्लैंपर, वोल्टेज डबलर, पीक डिटेक्टर। माय डियर फ्रेंड्स, this rectifier has some limitation, or that limitation is removed by operational amplifier, and we have to design the active rectifier, and that is called what? Precision rectifier. तो भाई जब मैं rectifier पढ़ूंगा, then I will give you the limitation of that, and then I will cover what? Precision rectifier, precision half wave rectifier, precision full wave rectifier. Okay, so my dear friend, in a precision rectifier we have to use the op-amp, and suppose we are not having any idea about the op-amp, then we have to learn this precision rectifier at the end of the session. तो relate नहीं कर पाओगे, what is the relation between this rectifier and that rectifier, right? What are the limitation and how those limitations are removed by the precision rectifier? That's why. Second, clamper. Again, this is the passive clamper. You will learn about the active clamper. Again, in active clamper, I'm going to use what? Operational amplifier. So again, op-amp is required. Then peak detector, we can design the peak detector by using op-amp also. तो यहाँ भी लगेगा. Then this is the BJT. Then voltage regulator. Again, in case of voltage regulator, we have to use what? Operational amplifier. तो again यहाँ भी लगेगा operational amplifier. यहाँ भी op-amp का यूज होगा, BJT, op-amp. Then this is the case, low frequency analysis of BJT. Then this is the okay. Again, in feedback amplifier, by what is the BJT, which type of feedback, FET, which type of feedback, operational amplifier, which type of feedback. So again, operational amplifier. Oscillator we are designing by using the operational amplifier, BJT, FET. Again, the op-amp is required here, right? And guys, operational amplifier is basically a direct coupled amplifier, and it is a differential amplifier. तो everywhere there will be the operational amplifier. अब आप मुझे बताइए कहाँ से चालू करना चाहिए? अगर हर जगह एडवांस वर्जन हमें op-amp से पढ़ना है, तो डेफिनेटली सबसे पहले हमें किस पे कमांड करनी चाहिए? ऑपरेशनल एम्पलीफायर पर। ठीक है, अब ऐसा नहीं है कि आप बिल्कुल सेमेस्टर एग्जाम में आ रहे हो, अभी तक के आपको आइडिया ही नहीं है कि कहाँ से क्या पढ़ रहे हो, आपको सब समझ में आएगा। तो सब मेंटली प्रिपेयर्ड हैं? ठीक, सिलेबस कवर समझ आया? देखो बोलोगे सर अब इसको 2 बार 3 बार, तो सिलेबस लिखो अपनी कॉपी में सब के सब, मतलब सोचते जाओ कौन कौन से टॉपिक इंपॉर्टेंट है एंड सो ऑन। तो ये काम सबसे पहले करना अगर एनालॉग में आपको कमांड करनी है। तो व्हाट अबाउट द डायोड सर्किट, व्हाट आर द एप्लीकेशंस ऑफ द डायोड सर्किट? ये इंटरव्यू में तुरंत क्वेश्चन पूछ देगा, बताओ क्या क्या एप्लीकेशंस है, तुरंत बोलना सर रेक्टिफायर, क्लिपर, क्लैंपर, वोल्टेज डबलर, पीक डिटेक्टर एंड नंबर ऑफ एप्लीकेशन लाइक सैम्पलिंग गेट्स, और भी मैं बहुत सारे बताऊंगा बीच में। फिर वो एक आध में रुको, टेल मी अबाउट द क्लिपर, व्हाट डू यू मीन बाय द क्लिपर, वहां से स्टार्ट होगा आपका इंटरव्यू। ओके, तो इसलिए अच्छे से ध्यान रखिएगा क्या है ये बेसिक्स। तो दिस इज द सेकंड, थर्ड एंड सो ऑन। तो मैंने बाद में कोई सीक्वेंस लिखा नहीं है, तो डोंट वरी अबाउट दैट। कितने चैप्टर हैं, क्या है, ये सब छोटी बातें हैं। सिलेबस कवर होना चाहिए, और सिलेबस आपके साथ कवर होना चाहिए, आपको समझ में आना चाहिए। ठीक है, जितने स्मॉल टॉपिक्स में बांट सकते हो बांट दो, जितना इस छोटे छोटे टॉपिक्स होंगे उतना ज्यादा आपको इजी लगेगा उस टॉपिक पे कमांड करने में। Right, and that is the operational amplifier. Okay, then I'm going to start with the operational amplifier. What is the operational amplifier? And then this is about the operational amplifier. At the end, I will give you the point. This is about the operational amplifier. Now, what is the operational amplifier? First, we have different types of amplifiers, guys. First of all, amplifiers. To understand the concept of amplifiers, remember we have the two types of signal. One is voltage signal, one is current signal. तो जो हम नॉर्मली यूज करते हैं इलेक्ट्रिकल सिग्नल वो है वोल्टेज सिग्नल और व्हाट करंट सिग्नल्स current signals. Okay, V and I. Then we can calculate the power V into what I. This is the power V into I. So normally that signal in terms of voltage or in terms of what current. Now we want to amplify the voltage. So we are having voltage at the input, voltage at the output. This is the voltage at the input, voltage at the output. So this type of amplifier is called voltage amplifier. Voltage amplifier, and this is the most commonly used amplifier. Voltage, we are giving the voltage at the input, we are getting the voltage at the output, and we are having the voltage gain here AV. So this is called V0 is equal to AVI. The most commonly used amplifier is what? Voltage amplifier. Okay, then next one is we are giving the current as an input and we are getting the current as output, because we have the two types of signal. So we are giving the current as an input, current as output. Then this type of amplifier is called current amplifier. It will amplify the current. So current gain is AI. So I0 is equal to AI into II. This is the current amplifier. Current amplifier. Then third one is we are giving the voltage as an input, we are getting the current as an output. What is the name of this amplifier, everyone? Voltage as an input, current as an output. Or finally, we are having current as an input, voltage as an output. Here the voltage is converted into current as well as amplified. Here the current is amplified and converted into what? Voltage. So basically we have the two signals. So voltage at the output, voltage at the input, then voltage gain is called V0 upon Vi, that is the AVVI. Voltage amplifier, current amplifier. When it will convert the current into voltage, I0 upon V. What is the gain? Everyone tell me. I0 upon V. This is called transconductance. I0 upon V. Transconductance amplifier. Transconduct, because trans we are using the word because we are dealing with the input and output, or amplifier means transconductance. GM is the conductance. Transconductance amplifier. Or here the V0 upon II, that is called RM, trans resistance amplifier. Voltage upon current is nothing but resistance. Trans resistance amplifier. Trans resistance amplifier. So in interview, if they will ask how many types of amplifier, then you can say how many types of amplifier, guys? 4 types of amplifiers. Voltage amplifier, current amplifier, transconductance, and what? A trans resistance amplifier. Why 4? Because we have the two signal, voltage and current. We can make the 4 combination like this: voltage voltage, voltage current, current voltage, current current. This is the 4 types of amplifier. Which one is the most popularly used amplifier? Voltage amplifier. Voltage amplifier. So here amplifiers, these are the signals. 4 types of amplifiers. Okay. Okay then. अब आते जरा आगे आइए. The most popularly used is what? Voltage amplifier. अब समझो कि एक black box है, like this is a voltage amplifier. Most popularly used is the voltage amplifier. It will amplify the voltage, like this is the V0, this is the VI. Voltage gain is AV. You can say the V0 upon VI is equal to AV. This is called voltage gain. Now my dear friends, this is actually a black box. There are number of components inside this box. Number of components, right? Transistor, MOSFET, anything. But you can represent this amplifier. At the input side, it should be replaced by its input resistance, and at the output side, it should be replaced by what? Thevenin's equivalent. So what is the equivalent of this diagram? बहुत सारे components हैं. Inside this, number of components are here. Number of components. But this black box can be represented by input resistance at the input side. We are getting the voltage VI here. Input resistance at the input side. What is the input resistance here? You can find that input resistance. And at the output side, it is represented by Thevenin's equivalent. Thevenin's equivalent, this is the R0. This is the AVVI. And this is the open circuit. Right, and this is called the equivalent of any voltage amplifier. ये बहुत ही important है, ध्यान रखना. Input side, it is represented by its input resistance. Output side, since we are getting the output voltage, and that's why it is represented by what? Output voltage V0. V0. Now, at the output side, this is the equivalent diagram. Always remember, this is the equivalent diagram. This Ri is called the input resistance of the amplifier. Ri. Input impedance or resistance amplifier. R0 is called output resistance or impedance of the amplifier, and AV is called what? Internal gain. This is the internal gain of the amplifier. Gain, right? A, this is the, remember, this is a small v, AV. It will amplify the signal that is coming across the Ri only. So it will amplify this one, AV. It may be 10, it may be 100, it may be 10 to the power 6, it may be infinite and so on. तो कभी भी इक्विवेलेंट ड्रॉ करना है तो आप यहाँ पर इसका, हमको नो आइडिया अबाउट द इनपुट, नो आइडिया अबाउट द इनपुट. Simply find the how many components are connected here. This is simply the black box. First of all, find the input impedance. Then second, find the Thevenin's equivalent, AVVI, and then R0. This is called the equivalent circuit of the voltage amplifier. अब देखो, मैंने यहाँ से start किया. हमको पढ़ना है operational amplifier, but there are 4 types of the amplifier: voltage, current, transconductance, transresistance. Most popularly used amplifier is a voltage amplifier. Draw the equivalent circuit of that voltage amplifier. You will get this type of equivalent circuit. Input resistance and Thevenin's equivalent. Now, you will get the property of the ideal voltage amplifier. Now, this is the equivalent circuit. This is the gain, AVVI. Okay, this is the equivalent circuit. Now, at the input side, we are going to connect what? A source. कोई भी आपने एक voltage source लिया वो connect करना है. For example, this is the amplifier. here you will connect a source. The voltage source has its internal resistance RS. We are connecting just to, we want to amplify this, or at the end we are connecting the RL. We are connecting the RL, and here we are getting the output voltage. Here we are getting the current I naught. Okay, output voltage V naught. So this signal will get amplified, and this is the amplifier, voltage amplifier. To draw the equivalent circuit of the amplifier, then connect RS. This is the VS. Then connect RL here. And the voltage across the RL is what? V naught. V naught. Now try to understand. This amplifier will amplify the voltage that is coming across RI only. Now we are connecting the VS. If suppose the RS is 0, then the complete voltage will come across the RI. But RS is not 0. If the RS is not 0, practically RS is not 0, that is the internal resistance of voltage source, then what is the condition so that the complete voltage will come across the RI? Tell me. What is the condition so that the complete voltage will come across the RI? क्योंकि जो RI के across है वही amplify होगा. What is the voltage coming across the RI? How? The complete voltage will come across the RI. RS is not 0, non-zero value. Then ideally RI should be infinite. If the RI is infinite, what is the current enter into this amplifier? Becomes 0. If the current will become 0, what is the drop across the RS? 0. And this will act as open circuit, therefore VI is equal to what? VS. Tell me, what should be the input resistance of the ideal voltage amplifier? Everyone tell me. What should be the input resistance of the ideal voltage amplifier? 0, infinite. क्या होना चाहिए? 0 or infinity? Input resistance. I am talking about the input resistance RI. क्या होना चाहिए प्रिया सपोल? 0. अगर आपने RI को 0 बना दिया, if the RI is 0, what is the voltage drop across the RI? It will become 0. If you are going to make the RI is equal to 0, VI will become 0. So RI should be infinite so that the current will be 0 and the complete voltage will come across the RI. Okay. Or practically it should be as high as possible. Practically it should be as high as possible. तो बताओ मुझे, अगर हम बोलते हैं practically it should be high, तो what about this line? Is it smaller one or bigger one? We can't say. Smaller one or bigger one, we can't say. So actually, ideally RI should be infinite. Practically RI should be as high as possible as compared to what? RS. As compared to RS. And that's why practically RI should be very, very, very greater than what? RS. देखो यहाँ पर लॉजिक देखना. According to voltage division rule, guys, according to voltage division rule, what is the VI? RI upon RI plus RS. यही होता है ना voltage division rule. R2 upon R1 plus R2 into what? VS. This is the voltage across the RI. If the RI is very, very greater than RS, RS is negligible. RI cancel out. What is the VI? Nearly equal to what? VS. Nearly equal to VS. तो हम चाहते हैं कि पूरा का पूरा ड्रॉप यहाँ आ जाए. और what is the current if the RI is infinite? Second benefit. What is the second benefit? What is the current enter into the amplifier? Right? Tell me. 0. If the current enter into the amplifier is 0, means what is the power dissipation? If the current is 0, then there is no power dissipation, negligible. Power dissipation is 0. That is the another benefit of this. So Ri is infinite, current will be 0, power dissipation is negligible. Right? Power dissipation is negligible. So yeah, this is the first property. So first, ideally, it should be infinite. Practically, it should be very, very high. Remember, RS is not 0. अच्छा एक बात बताओ, हम किसकी बात कर रहे हैं? हम वोल्टेज सोर्स डिजाइन कर रहे हैं कि एम्पलीफायर? एवरीवन टेल मी. क्यों अनमोल? वी आर डिजाइनिंग द वोल्टेज सोर्स और वी आर डिजाइनिंग द एम्पलीफायर? वी आर क्या कर रहे हो? एम्पलीफायर ना. जब एम्पलीफायर डिजाइन कर रहे हो तो फोकस ऑन द एम्पलीफायर. कृष्णा रोबोटिक्स, व्हाई यू आर टॉकिंग अबाउट द आरएस? If we are designing the voltage source, then we will think how we are going to make the RS is equal to 0. लेकिन आप क्या डिजाइन कर रहे हो? एम्पलीफायर्स. तो हमारे कंट्रोल में क्या है? RI, R0, AV. RL is not our control. RS is not in our control. So if you want to transfer the complete voltage, what should be the RI? Ideally infinite, or practically it should be very, very greater than RS, minimum 10 times. Minimum 10 times. Okay? No doubt. You can say, sir, RS should be equal to 0. Yes, you can say. If the RS is 0, the complete voltage will come across the RI. But we are not designing the voltage source. We are designing what? Amplifier. So amplifier RI should be infinite, RI should be very, very greater than RS, and that is important. क्लियर हो गया? क्यों होता है ऐसे, क्यों बोलते हैं? क्योंकि हमको एम्पलीफायर डिजाइन करना है, इसलिए पूरी देखो कंडीशन एम्पलीफायर पर है. ओके देन, नाउ नेक्स्ट. किसी को डाउट अप टू दिस पॉइंट? अप टू दिस पॉइंट एम्पलीफायर्स, ऑल द 4 टाइप्स ऑफ एम्पलीफायर्स आर क्लियर? क्लियर हुआ? ओके. अब आते हैं, देखो आर नॉट क्या होना चाहिए. तो आर नॉट जो है, वो दिमाग में बैठा लो ना सब कुछ. एम्पलीफायर्स, करंट एम्पलीफायर्स, ट्रांस कंडक्टेंस एम्पलीफायर एंड सो ऑन. ठीक है, उसको सबको देखो जरा. एक मिनट, फोन आ रहा है कुछ, कहाँ है ऑफिस से ही. ओके, तो ये हो गया यहाँ तक क्लियर. आप देखो ये एम्पलीफायर्स में बाकी भी पढ़ेंगे, ये भी ट्रांस कंडक्टेंस, ट्रांस रेजिस्टेंस, ये आपका फीडबैक एम्पलीफायर में आएगा, डिटेल अबाउट दिस, डिटेल अबाउट दिस, डिटेल अबाउट दिस, बट नाउ वोल्टेज एम्पलीफायर इज इंपॉर्टेंट। तो दिस इज द वोल्टेज एम्पलीफायर, उसका इक्विवेलेंट ड्रॉ करो, इनपुट रेजिस्टेंस थेवेनिन्स एंड आर नॉट इज द आउटपुट रेजिस्टेंस। Then first of all get the idea about the input resistance. Practically it should be very high, ideally it should be infinite. Complete voltage will come across that and II will be 0, power loss is 0. अब बात करते हैं आउटपुट रेजिस्टेंस की। What about the output resistance, guys? Now this amplifier will amplify the signal across the RI only. So this is the amplified version AV into VI. AV is the small AV, na, remember. AV is the small AV and that is called the internal gain of the amplifier. Now we want to transfer this complete amplified voltage across the RL. If you want to transfer this across the RL, so what should be the drop across the R0? 0. So ideally the value of the R0 should be equal to what? 0. If this is 0, then what is the V0? The complete voltage will come across this. AV into what? VI. So complete voltage will come across the RL and we want to transfer the voltage, amplified voltage across the RL. Now practically not possible. When we are designing the circuit, it is not possible to make it what? 0. Because we are connecting some soldering and so on. So it is not possible to make it 0. So what we are doing, R0 should be very less. When I am saying that R0 should be very less, again there is a comparative term. Tell me guys, this line is a smaller one or bigger one? This line is a smaller one or bigger one? We can't say. It is comparative term. So R0 should be small as compared to what? RL. R0 should be very small as compared to RL. अब इससे क्या होगा? Now according to voltage division rule, tell me what is the V0? V0 is equal to AVVI. This is the voltage at this point. You want the voltage across the RL, so it should be divided by R0 plus RL and multiplied with the RL. This is called voltage division rule. If the R0 is very less than RL, what will happen? If the R0 is very less than RL, R0 is negligible, this RL cancel and output will become AV into what? VI. So this is the case, guys. Okay, so this should be very small. That is the second property and ideally it should be equal to what? 0. It should be equal to 0. Then third one. Third case, दो property हो गई. Third property, what we want actually, gain. The gain should be as high as possible. This gain, internal gain should be as high as possible. If you want the gain should be as high as possible, how is it possible then? Gain कैसे लाएं भाई? This gain. So ideally we want this gain should be what? Infinite. Now why you want the gain should be infinite? Now try to understand why we want the gain should be infinite. Okay, gain should be infinite. Try to understand. Suppose you are having any amplifier and you want output. For example, you want the 5 volt as a output. अच्छा एक बात बताओ, ईमानदारी से बोलना ना, उधर उधर की बातें मत करना. आपको रिजल्ट चाहिए कि नहीं चाहिए गेट का? यस और नो? अरे मैं जो क्वेश्चन पूछ रहा हूँ, यस चाहिए. आपको पढ़ाई भी चाहिए अच्छे से, यस और नो? आपको पढ़ाई चाहिए ना? यस. अरे एकदम अपना सच्ची जवाब देना, उल्टा सीधा इधर उधर की बातें नहीं करना. कितना फीस देना चाहते हो आप बताओ ईमानदारी से, मतलब मन से दिल से बोलो कि क्या चाहते हो, कितनी फीस? अरे तुम कृष्णा ज्यादा इधर उधर बातें मत करो, एकदम आइडियल कंडीशन बोलो, कितनी फीस देना चाहते हो? सब के सब झूठ नहीं, इधर उधर की बातें नहीं. मैं आपको वरदान दे रहा हूं, मांगो. अरे मिनिमम अनमोल, हाँ अनमोल ठीक बोल रहे हैं. मिनिमम कितना? चलो आइडियल बोल रहा हूं मैं, मिनिमम कितना? बोलो 0, यस और नो। नेहा बिल्कुल सही है ना। अच्छा एक बात बताना नेहा, एकदम ईमानदारी से, अगर मतलब आपको गेट का रिजल्ट मिल जाए और मैं आपसे बोलूं पढ़ना भी नहीं पड़ेगा, कैसा लगेगा आपको बताओ? मतलब बिल्कुल भी नहीं पढ़ना और आपको बिल्कुल मतलब कोई बदमाशी नहीं करेंगे, आपको तथास्तु बोलूंगा और वरदान मिलेगा और आपको मिल जाएगा। बोलो कैसा लगेगा सबको? अरे अच्छा कि बुरा, गुड और बैड, यही बताना है। ये भाषणबाजी नहीं कि अरे सर मतलब मैं तो मेहनत के बिना कुछ लेना नहीं है, ये वो फालतू की बातें नहीं, है ना। बढ़िया ना, अमेजिंग फीलिंग है, ठीक बात है। तो भाई मेरे ध्यान देना, वही मैं बात बोलना चाह रहा हूँ। अभी अभी राकेश तुम गुड में ही अटके हो, ग्रेट, बहुत ही हाई हाई चीज बात कर रहा हूँ, मतलब बिना कुछ किए वाह खजाना मिल गया एक, वाह यार। और अभी मैं आपको खजाना दे दूं ना तो कोई यहाँ पे गेट की तैयारी नहीं करेगा, सब भाग जाएंगे। ये सच्चाई है, बहुत ही इक्का दुक्का होगा कोई पढ़ने के लिए पढ़ रहा है, सब के सब जॉब और उसके लिए पढ़ रहे हैं, मानते हो? है ना, यही है ना सच्चाई, कि सब के सब जॉब या मतलब कुछ अच्छा लुक्रेटिव मिल जाए और अभी आपको खजाना मिल जाए, सब पढ़ना बंद। तो जिस दिन भी आपको खजाना भी मिल जाए ना, ध्यान रखना उस दिन भी आप पढ़ाई मत छोड़ना, और उस दिन भी उस दिन भी कुछ नया इनोवेशन करना, तब मजा आएगा आपको। तो चलिए आते देखते हैं। तो देखो जरा, यू वांट आउटपुट, यस, यू वांट सम आउटपुट। नाउ हाउ मच इनपुट यू वांट टू गिव? यू वांट टू गिव 0 इनपुट, you want to give the 0 input in terms of money as well as in terms of efforts, yes. Now tell me guys, if you want the finite output or without any input, what should be the gain of the system? The gain is given by V naught upon Vi. You want the 5 volt as output or anything as output, but you want to give the 0 as an input, what should be the gain of the system? The gain of the system should be what? Infinite. And that is called what? Ideal condition. अगर gain का अगर infinite अगर हो जाए तो अगर there will be the output without any input. If the gain is infinite, there will be finite output without input. Any input, and that's why we want the gain should be as large as possible. Okay, clear हुआ पॉइंट? हाँ हमारे GFG में तो अफोर्डेबल है ही है। अब बताओ, इतनी सारी क्लासेस हो गई, ईमानदारी से जितने लोगों ने भी नेटवर्क पढ़ा है, अभी EDC चल रहा है, कोई आपको कोई प्रॉब्लम है? मतलब समझ आ रही बात? क्या लगता है आपको? मतलब जितने लोगों ने भी जो फीस दी है अभी तक, क्या लग रहा है आपको? ठीक है मतलब फीस देना वर्थ लगा कि नहीं लगा, ये बताओ। नेटवर्क हो गया, EDC चल रहा है, कुछ लोगों ने नया ज्वाइन किया, उनके मोटिवेशन के लिए ही बोल दो कि आपको सही लग रहा है, कोई गलत जगह तो नहीं आ गए हो आप लोग? ऐसा तो नहीं लगा अरे यार कहाँ आ गए, कोई पढ़ाई नहीं रहा है, टाइम पास ना, उसके कॉन्सेप्ट क्लियर है, पूछो तो कुछ बताते नहीं, डांट देते हो। स्वामी की ईमानदारी से कितनी बार डांट खाए हो अभी तक मुझसे? अभी तक कितनी बार डांट खाए हो कि मैंने बोला डफर, कुछ नहीं आता, कुछ भी पूछ रहे हो, क्लास डिस्टर्ब कर रहे हो? ऐसा कब बोला मैंने? इतने घंटे में पढ़ा चुका हूँ, कभी भी मुझसे सुना है आपने ऐसा? मैंने बोला यू डफर, नो आइडिया, थोड़ा चैप्टर वैप्टर पढ़ के नहीं आते हो, कुछ भी पूछ रहे हो, है ना? मुझे कभी गुस्से में देखा ही नहीं होगा कि सर गुस्सा कर रहे हैं या भड़क गए या कुछ बोल रहे हो या चिल्ला के बोल रहे हो, है ना? तो जरूरत ही नहीं है उसकी, क्या जरूरत है चिल्लाने की? आराम से पढ़ो, आराम से क्वेश्चन पूछो, आराम से हंसी मजाक करो। हंसी मजाक या जोक्स भी होता है, या मैं मूवी का भी कोई नाम ले रहा हूं ना तो वो भी रिलेवेंट है, उसको भी अपन लोग को लिंक करना है ताकि वो चीजें याद आए, जब इंटरव्यू में पूछे तो रिकॉल करें। कोई बोलोगे अच्छा सर बोले तो मेरे को तो फीस 0 देने का मन है, तो 0 से आपको याद आ जाएगा द गेन शुड बी व्हाट? इनफाइनाइट। तो ऐसा आप अगर करते हो ना तो चीजें बहुत इजी तरीके से याद आती है। अब देखो, व्हाट शुड बी द गेन ऑफ द सिस्टम? इनफाइनाइट। तो देयर विल बी फाइनाइट आउटपुट विदाउट एनी इनपुट। अब आ गया AV इज इक्वल टू इनफाइनाइट। ओके, अब कैसे लाएं? एक एम्पलीफायर का तो गेन फाइनाइट होता है, तो बोले ढूंढो जरा, बोले जा ले आओ सबको बुलाकर, बोले क्या हो गया, बोले चाहिए यार सिस्टम का गेन क्या चाहिए, इनफाइनाइट चाहिए। बोला ओके चलो भैया इनफाइनाइट गेन बनाएंगे। ध्यान दीजिएगा, अब देखो ये लगाया एक एम्पलीफायर, फिर दूसरा, फिर तीसरा, ఒకటి రెండు మూడు నాలుగు ఐదు ఆరు and so on, right? And let the gain of the each amplifier is 10 10 10 10 10 and 10. Now if the gain of the each amplifier is 10 10 10 10 10, and that is called cascading. What is the meaning of the cascading? When the output of the first stage will become input for the second stage. Output of the first stage, second, third, fourth. So this is called cascading or multi-staging. What is the name here? Cascading. Cascading or multi-staging. Okay. Now, if you are using the one amplifier, if you are giving the any signal, it will become 10V. Then it will become 100V after that. Then it will become 1000V. Then it will become what? 10 to the power 4V, 10 to the power 5V, 10 to the power 6V. This is multiplied with the 10, 10, 10, 10, 10, 10, 10. So tell me guys, what is the gain of the system? This is the Vi, this is the V naught. So what is the gain of the system? All are 10 and that's why it will become 10 to the power 6. Clear? We are just multiplying the gain. 1, 2, 3, 4, 5, 6. Now we want infinite gain. What should be, how many number of amplifiers are required? Tell me. How many numbers of amplifiers required if you want the infinite amplifier? If you want what infinite gain? Tell me. कितने amplifier लगेंगे? If you want the infinite gain, then infinite number of amplifiers are required. Yes, practically it is possible. You can connect the number of amplifiers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and so on up to what infinity, and you will get the infinite gain. Okay. तो लगा दो, हो गया, हमारी रिक्वायरमेंट पूरी हो गई। देखो ये देखो, what you want, AV is equal to infinite, there will be the finite output without any input, then connect the infinite numbers of amplifiers, then we are getting the infinite gain. Okay. Now try to understand, if the delay of the single amplifier is, for example, we are giving the input, we are getting the output, so definitely there will be the some delay. This is called propagation delay. Propagation delay. Propagation delay. Like this is only 10 nanosecond. 10 nanosecond. Propagation delay is 10 nanosecond. So what is the delay for the two stage? The delay for the two stage will become 20 nanosecond. Delay for the three stage will become 30 nanosecond. 60 nanosecond. If you are going to use the infinite number of amplifiers, what will be the delay? If you are going to use the infinite amplifiers, what will be the delay? Delay will be also infinity. अगर डिले भी इनफाइनाइट है तो क्या हुआ पता है आपको? सिग्नल अंदर गया, वापस ही नहीं आया। मतलब यहां से सिग्नल दिए, आज तक आए ही नहीं वापस. Never come out from this. Why? Because the propagation delay is what? Infinity, right? So we are not getting any signal. So therefore, practically it is not possible to connect infinite number of what? Amplifiers. ये मत बोलो, sir, it is not possible to design the infinite number of amplifiers. It will take large time to design and we have to connect it, and that's why it will consume more space. है ना, इंटरव्यू में पूछेगा ना क्यों नहीं है पॉसिबल, तो आप बोलोगे ना सर इतने सारे एम्पलीफायर कहाँ से लाएंगे, अच्छा चलो ले आओगे, फिर और इस बार इतना सारा ले आएंगे तो स्पेस कहाँ है हमारे पास लगाने के लिए, फिर बोलेगा चलो स्पेस भी दे दिया मैंने आपको, लगा लो। अब फिर आप क्या बोलोगे, मैटर क्या कर रहा है, डिले, प्रोपोगेशन डिले। तो प्रोपोगेशन डिले विल आल्सो बिकम इनफाइनाइट एंड दैट्स व्हाई वी हैव टू टेक व्हाट ट्रेड ऑफ बिटवीन दैट, ट्रेड ऑफ बिटवीन दीज टू गाइस। ओके, देखो रुक जाओ, मेरी पहली क्लास है तो कहीं डिस्टर्ब। एनी डाउट देन प्लीज आस्क। ओके, तो वी कांट कनेक्ट द इनफाइनाइट नंबर ऑफ, दिस इज द क्वेश्चन इन इंटरव्यू कि क्यों नहीं होता, तो ये देखो वी हैव टू कनेक्ट द लिमिटेड नंबर ऑफ व्हाट एम्पलीफायर्स, तो वी आर कनेक्टिंग द मल्टी स्टेज एम्पलीफायर्स, तो वी आर एक्चुअली बेसिकली वी आर कनेक्टिंग द 6 एम्पलीफायर्स, then and remember guys this is called multi staging, this is called what, multi staging. Then delay will become infinite. Second thing, ideally what is the value of the delay, so ideally you want delay should be equal to 0, ideally you want delay should be 0, ideally you want gain should be infinite, and bandwidth, remember third thing is what, bandwidth. Bandwidth is inversely proportional to delay. More will be the delay, less will be the bandwidth. And what is the meaning of the bandwidth? Try to understand. Meaning of the bandwidth is we want to amplify the signal, guys. We want to amplify the signal from 0 to what? Let for example, this is called frequency response curve. This is called what? Frequency response curve. This is the frequency, this is the gain. We want the bandwidth should be infinity. Bandwidth should be infinite. What is the meaning of this bandwidth should be infinite? Means a particular amplifier can amplify the signal at 0 hertz, that is called DC signal. It can amplify the signal in the range of megahertz. It can amplify the signal in the range of gigahertz. It can amplify the signal in the range of what, 10 to the power 16 hertz, and so on, and up to what, infinite. And up to infinite, the variation of the frequencies from 0 to infinity, or the gain should remain what, constant. There should be no variation in the gain. Bandwidth, ideally what is the required bandwidth? Infinite. The bandwidth, that should be what, infinite. The range of frequency for which the gain should remain independent of variation in frequency. Frequency will vary, but the gain is not varying. For example, the gain is 10, it will remain 10. Whether it is 0 frequency, whether it is megahertz, gigahertz, or what, 10 to the power 16, or what, infinite. Ideally, But what is the delay? Bandwidth is inversely proportional to delay. So guys, there is a contradiction between these two. We want two things. Gain should be infinite. We want bandwidth should be infinite. That is, delay should be 0. Delay should be equal to 0. If you are increasing the delay, bandwidth will reduce. Okay. दो है. Just to increase the gain, we are doing the multi-staging. Just to increase the gain, we are doing the multi-staging. Okay. But when we are doing the multi-staging, try to understand. If there is a 0 stage, what is the delay? Everyone tell me. There is no stage. What is the bandwidth? What is the delay? कोई है ही नहीं, कोई स्टेज ही नहीं है, सीधा सिग्नल जा रहा है. What is the delay? Everyone tell me. This is the no stages. What is the delay? 0. So what will be the bandwidth? If there is 0 stage, delay is 0. Bandwidth is what? Infinite. But what is the gain? 0. भाई कोई स्टेज ही नहीं है, तो what will be the gain? 0. Okay. When I am connecting the stage, the gain will increase, but delay increases. What about the bandwidth? Decreases. So my dear friend, it is a contradicting in nature. When I am increasing the gain with the help of the stages, delay will increase, bandwidth will reduce. Bandwidth will what? Reduce. Now, actually what we want, the gain should be high, bandwidth should be high, but problem is there, when we are increasing the gain, bandwidth decreases. Means one thing is constant here. For any particular amplifier, always remember, any particular amplifier, the gain bandwidth product is always constant, guys. Remember, for any amplifier, this is the important term, gain bandwidth product. This will remain constant. For example, if we are using the single stage amplifier, for this amplifier, the gain is like 10, bandwidth is 100 hertz, means this is the gain 10, this remain constant up to this point, and then after that it will reduce. So up to which point it will remain constant? Up to what? 100 hertz it will remain constant. So gain will become 10, bandwidth will become 100 hertz. This is called bandwidth, the band of frequency for which it will remain constant. Now for this amplifier, always remember the gain bandwidth product, this is called GBW. Gain into bandwidth. What is the gain? 10. What is the bandwidth? 100. This is the 1000 hertz. This will remain constant. Remember, this will remain constant. A problem क्या है? What is the problem? If suppose I want to increase the bandwidth up to what? 1000 hertz. If the bandwidth is 1000 hertz, the gain bandwidth product will remain constant. Tell me what is the gain? Everyone tell me. If you want the bandwidth become 1000 hertz, so what is the gain? What will be the gain? Product will remain constant, the gain will become 1. Okay, if you want the bandwidth 10,000 hertz, what should be the gain? 0.1. If you want the bandwidth, this is the 10 to the power 6. What should be the gain? 0.01. Okay, and so on. So my dear friends, if you want to increase the bandwidth, you have to reduce the gain. Okay, tell me, if any amplifier has the gain 1 or less than 1, is it amplifier? If any device has the gain 1 or less than 1, is it an amplifier? अरे भाई amplifier नहीं है ये, attenuator है ये. This is an attenuator, not an amplifier. So what is the basic definition of an amplifier? The gain should be 1 or more than 1. For amplifier, for amplifier, gain should be greater than or equal to 1. So this is not an amplifier. So tell me guys, in this case, what is the highest bandwidth possible for single stage? Everyone tell me, what is the highest bandwidth possible? If the gain bandwidth product is constant, we can reduce the gain or we can increase the bandwidth. The highest bandwidth possible is only 1000 hertz. Why? We will reduce the gain up to 1. कैसे reduce करोगे? With the help of negative feedback. With the help of negative feedback, we will reduce the gain. So what should be the lowest gain? 1. What is the highest bandwidth? 1000 hertz. This is the highest. Maximum. Not possible more than that. Not possible more than that. Now, this is the logic behind that device. सबसे important concept I am going to discuss for operational amplifier. सभी alert हैं अभी भी? सब alert है ना? मतलब पॉपकॉर्न खाने तो कोई नहीं चला गया कहीं? पता चला मूवी में एकदम क्लाइमेक्स आने वाला है, बिल्कुल पूरे राज खुलने वाले हैं कि क्यों इतना कहानी है, और पता चला आप चले गए बाहर घूमने फिरने, बोले ऐसा तो नहीं ना? पीवीआर में पॉपकॉर्न खरीदने जा रहे हो आप लोग? आ जाओ आप, चलो कोई बात नहीं। अब देखो, तो फॉर अ सिंगल स्टेज द गेन इज 10, बैंडविड्थ इज 100 हर्ट्ज, द गेन बैंडविड्थ प्रोडक्ट इज कांस्टेंट, दिस विल रिमेन कांस्टेंट ना, दिस विल रिमेन कांस्टेंट, this will remain constant. So when we are increasing or decreasing the gain with the help of negative feedback, bandwidth will increase, but only the 1000 hertz bandwidth is possible in that case. Okay, now what we are doing actually, when we are doing the multi-staging guys, so what is the basic purpose of the multi-staging? Now try to understand. When I am connecting the number of stages, right, number of stages, let for example 6, the gain will no doubt increases, gain increases 10 to the power 6, no doubt. Overall bandwidth will reduce, because when we are increasing the number of stages, the bandwidth will reduce. Now the bandwidth will become 1 hertz, overall bandwidth will become 1 hertz, overall bandwidth will become 1 hertz. So what is the drawback of the cascading? Gain increases, bandwidth decreases. No use of this, no use of this. Why? The gain is very high, my dear friend, the gain is very high, but what is the bandwidth? Negligible. You can't amplify the signal more than 1 hertz. No use, because our audio frequency is what? 20 hertz to 20 kilohertz. Our audio frequency is from 20 hertz to 20 kilohertz. So how we can amplify the signal? Right? The gain is very high, but it is constant up to what? 1 hertz. So no use of this cascading. No use of this cascading. But what is the advantage of this cascading? What is the gain bandwidth product? Calculate the gain bandwidth product for this. Shomik, what is the gain bandwidth product for this multi-staging, after multi-staging? If you are going to calculate the gain bandwidth product, what is the gain and what is the bandwidth? The gain become 10 to the power 6, bandwidth is 1. So what is the gain bandwidth product? 10 to the power 6 hertz. What was the gain bandwidth product for single stage? The gain bandwidth product for the single stage was 1000 hertz. What is the gain bandwidth product for multi-stage? Gain is very high, no doubt, bandwidth is very low. The gain bandwidth product is what? 10 to the power 6 hertz. When I am comparing with the single stage, it is 1000 times high. Okay. So what is the one of the most important advantage and what is the basic purpose of multi-staging is not to increase the gain, not to decrease the bandwidth. It is to use to increase what? Gain bandwidth product. तो ये gain bandwidth product बढ़ गया. अब बोले अब सर क्या करें इसका? Now try to understand. Now for multi-staging, the gain is 10 to the power 6. No doubt the bandwidth is only 1 hertz. Gain bandwidth product is 10 to the power 6 hertz. Now I am going to use the negative feedback. Now I am going to use the negative feedback. Multi-stage amplifier with negative feedback. Okay. अब आप क्या करो, नेगेटिव फीडबैक लगाओ. बिकॉज ऑफ द नेगेटिव फीडबैक गेन रिड्यूसेस. आप बोलोगे सर गेन कितना था? 10 to the power 6. What was the bandwidth? 1. What was the gain bandwidth product? 10 to the power 6. Now I am reducing the gain. Multi-stage amplifier, I am reducing the gain again 10. After feedback gain become 10. Okay, तो आप बोलोगे सर क्या टाइम पास कर रहे हो? Already that was the gain is 10. Initially for single stage the gain was 10. Again you are saying that gain is 10. But in a single stage what was the bandwidth? 100 hertz. What was the maximum possible bandwidth? 1000 hertz. Now try to understand this concept. When I am connecting the negative feedback, the gain become 10. Everyone tell me what is the gain bandwidth product? What is the bandwidth? The bandwidth will become gain bandwidth product upon gain. This is the 10 to the power 6 upon 10. The bandwidth is 10 to the power 5 hertz, means 100 kilohertz. 100 kilohertz. Now compare with the single stage. Now compare with the single stage. The gain is 10 and it is constant up to what? 100 kilohertz. It is constant up to 100 kilohertz. For single stage, the gain was 10 and it is constant up to what? 100 hertz only. For multi-stage, the gain is the 10, but it is constant up to what? 100 kilohertz. Now, if you want to amplify the signal from 20 hertz to 20 kilohertz, yes, it is in the range. Yes or no? Yes, it is in the range. Yes or no? This is the 20 hertz. This is the 20 kilohertz. So this is the multi-stage with the negative feedback. We are reducing the gain, we are increasing the bandwidth. Achha, tell me, what is the maximum possible bandwidth, everyone? Q Anmol, Somik. What is the maximum possible bandwidth for multi-stage amplifier? For multi-stage amplifier, what is the maximum possible bandwidth? Maximum possible bandwidth means the gain is lowest. The gain should be minimum after feedback. What is the minimum gain? 1. So what is the bandwidth available after feedback? 10 to the power 6 hertz. 1 megahertz. 1 megahertz. And what was the bandwidth possible in case of single stage? Only 1000 hertz. 1 kilohertz. 1 kilohertz, and it is reached up to what? 1 megahertz. So I am going to conclude it. What is the multi-staging, guys? Why we are doing the multi-stage? To increase the gain or to increase the bandwidth? What is the purpose of the multi-staging? We want to increase the gain actually, or we want to increase the bandwidth? Actually we want to increase the bandwidth. So देखो पूरा bandwidth का खेल है. Bandwidth means the band of frequency for which the gain should remain constant. So what are the limitation of the single stage? In a single stage, the no doubt gain is 10, okay, sufficient gain, but the bandwidth is very, very low. We can't increase the bandwidth. It is constant up to 100 hertz. So what we are doing the multi-staging. When we are doing the multi-staging, in open circuit, gain will increase up to 10 to the power 6. Bandwidth will highly reduce. That is the drawback, 1 hertz. But biggest advantage is gain bandwidth product increases. This is the gain bandwidth product increases. Now, it is no use, useless. Useless. Right? Now, then we are connecting the multi-stage amplifier with the negative feedback. With the help of negative feedback, we are reducing the gain again up to 10. That is the gain of the single stage. But this time we are getting the more bandwidth up to what? 100 kilohertz. Our purpose is solved. Our purpose is solved. तो when we are comparing with the single stage, gain is 10. In case of single stage, gain is 10. What was the bandwidth? Only 100 hertz, but this time the bandwidth is what? 100 kilohertz, and that is the basic purpose. Clear हुआ? सबसे इंपॉर्टेंट है ये, यही इंटरव्यू में आपको बोलना है. अब चाहे जैसे बोल लो, आपको सर मुझे बैंडविड्थ बढ़ानी है, बैंडविड्थ बढ़ाने का एक ही तरीका है, पहले करो मल्टी स्टेजिंग, फिर लगाओ नेगेटिव फीडबैक, नेगेटिव फीडबैक से गेन को कम करो और बैंडविड्थ को इंक्रीज करो. राइट, तो ये हो गया कहानी. तो दिस इज द केस. तो गाइज, फॉर एनी आइडियल ऑपरेशनल एम्पलीफायर व्हाट आर द प्रॉपर्टीज? फॉर एनी आइडियल ऑपरेशनल एम्पलीफायर, my dear friend, the main property is what? Ri should be what? Infinite. R0 should be equal to 0. Gain we want it should be infinite. Bandwidth we want it should be infinite. If you want the gain infinite, bandwidth infinite, means actually you want the gain bandwidth product should be infinite. Gain bandwidth product should be infinite. These are the property of the ideal voltage amplifier. Okay. अब आइडियल वोल्टेज एम्पलीफायर की ये सब प्रॉपर्टी चाहिए भैया, ऐसा 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 होना चाहिए. तो बोले भैया ढूंढो मार्केट में, जाइए चाहिए मार्केट में ढूंढ के लाओ, कोई ऐसा है क्या? इज देयर इज एनी डिवाइस विच हैज ऑल दीज प्रॉपर्टीज? आर आई इनफाइनाइट, आर नॉट जीरो, एवी इनफाइनाइट, बैंडविड्थ इनफाइनाइट, गेन बैंडविड्थ प्रोडक्ट शुड बी इनफाइनाइट. इट शुड एम्पलीफाई द 0 hertz frequency as well as infinite hertz frequency. It can amplify the 0 hertz frequency, means DC signal. ओके, ढूंढा गया? नो, नॉट अवेलेबल. तो यहां पर जरूरत पड़ी एवेंजर्स की. जस्ट नाउ द एवेंजर्स आर रिक्वायर्ड. तो व्हेन द एवेंजर्स आर रिक्वायर्ड मींस इट इज नॉट पॉसिबल टू डिजाइन दिस टाइप ऑफ एम्पलीफायर. तो वी आर डिजाइनिंग विद द हेल्प ऑफ व्हाट? वी आर डिजाइनिंग विद द हेल्प ऑफ डिफरेंट टाइप्स ऑफ एम्पलीफायर्स. फर्स्ट ऑफ ऑल, this type of amplifiers, ideally what we are doing the multi-staging to increase the gain bandwidth product first of all, right? Then second thing, at the input we are connecting a circuit whose input resistance is very very high, like infinite. At the input we are using the circuit whose input resistance is very very high. For example, differential amplifier, emitter coupled differential amplifier, or what common collector configuration. So this is important one. We are using this one because its input resistance is very high as a input stage. It is also called direct coupled amplifier because we want to amplify the DC signal. This is the direct coupled amplifier. What is the direct coupled? I will explain. At the output we are using the circuit whose output resistance is very low. Ideally it should be 0. So it is a for common collector configuration. So in a BJT, in EDC, you will learn about the common collector, common emitter and common base. There are 3 configuration: common emitter, common collector, common base. So in case of common collector, output resistance is very very small, and that's why we are using. In intermediate stages, we are using the stages for which the gain is high, moderate. We want the gain. So normally in intermediate stages, common emitters are used. Common emitters are used. Here we are using the differential amplifier. So this complete circuit is known as what? Operational amplifier. So operational amplifier is not a single stage amplifier. Operational amplifier is what? Multi-stage amplifier. For operational amplifier, we are doing multi-staging. What is the basic purpose behind the multi-staging? To increase the gain bandwidth product. At the input side, we are using a high input resistance device to make the Ri ideally infinite. At the output, we are using the common collector to reduce the output resistance. Right? Third thing, why we are using the direct coupled? Direct coupled means, finally, direct coupled means why the operational amplifier is a direct coupled amplifier. We want to amplify the DC as well as AC. But normally in amplifier, at the input we are connecting the capacitor like this. Last topic, capacitor. Input में हम लोग क्या करते हैं ना, कैपेसिटर लगा देते हैं. क्यों लगाते हो भाई कैपेसिटर? कोई पूछेगा क्यों लगा दिए कैपेसिटर? Try to understand. When we are connecting the capacitor, The impedance because of the capacitor is 1 by omega c or 1 by 2 pi fc. For DC, omega is equal to 2 pi f is equal to 0. So what is the impedance? Infinite. Capacitor acts as open circuit for DC. So when we want to amplify the signal, AC signal, 20 hertz to 20 kilohertz. For example, my audio signal is AC signal. So when I want to amplify the AC signal, then in that case, I want to avoid what? DC signal. I want to avoid the DC signal. That's why I'm using the capacitor. This capacitor will allow the AC signal and it will stop the DC signal. Why? Because it is a act as open circuit. This is called DC blocking capacitor. It will pass the AC signal, but it will stop the DC signal. But my dear friends, tell me, if I want to amplify the DC, so I have to remove this capacitor. Yes? Yes or no? If suppose I want to amplify the DC signal, then I have to remove this capacitor. When I am removing the capacitor, this is called direct coupled. When I am removing the capacitor and directly connecting this is called direct coupled. Or when we are using the capacitor, this is called resistor capacitor coupling. This type of circuit is called resistor capacitor coupling. Resistor capacitor coupling. Or when there is no capacitor, it is called direct coupled. So direct coupled amplifier can amplify what? DC as well as what? AC, both. So op-amp is actually a direct coupled amplifier. It can amplify the DC signal as well as AC signal up to what? Megahertz range. So bhai sahab, this is the story about the ideal voltage amplifier, but practically the ideal voltage amplifier is not available. So we have to design the ideal operational amplifier by using the different superheroes like what? Iron Man, Thor, and what? Mr. America, और वो कौन है? Natasha, and so on. ठीक है? So just we are connecting at the input direct emitter coupled differential amplifier. At the output we are connecting the common collector. In between we are connecting the common emitter configuration. We are doing the multi-staging and we are getting the properties. Ri very high, R0 very low, gain bandwidth product very high, and so on. Okay, and that is the operational amplifier, guys. Clear हुआ? इतनी कहानी ऑपरेशनल एम्पलीफायर के पीछे. तो आपसे क्वेश्चन तो थ्योरेटिकल बन गए, लेकिन आपको साथ में बहुत सारे बेसिक इंटरव्यू के क्वेश्चंस क्लियर हो गए यहां से. क्यों इतना मैंने इसको लिया है. यहां तक कहीं किसी को कोई भी डाउट है तो बताइए भाई. एनी डाउट? तो इनिशियली क्यों बनाया गया था पता है ऑपरेशनल एम्पलीफायर? व्हाई इट इज डिजाइन? सिंपल मैथमेटिकल ऑपरेशन करने के लिए. एडिशन करवा दो यार, सब्ट्रैक्शन करवा दो, मल्टीप्लिकेशन हो जाए, डिवीजन हो जाए. तो इनिशियली इट इज डिजाइन टू डू द मैथमेटिकल ऑपरेशंस like what? Addition, subtraction, multiplication, division, and that's why it is called operational amplifier. सिंपल मैथमेटिकल ऑपरेशन करने के लिए इसको डिजाइन किया गया था. इट इज अ 8-pin IC. Most popularly used IC is IC 741. Power supply is what? 15 and minus 15 volt. Normally we are giving the 15 and minus 15 volt DC supply. Without energy, energy can neither be created nor be destroyed. तो अगर जो भी काम करवाना है, सिग्नल को एम्पलीफाई करना है, you have to apply the DC signals. तो यहाँ पर 15 और माइनस 15 का सिंबल लगाया जाता है. तो ये है अबाउट द ऑपरेशनल एम्पलीफायर. चलिए आप रीड करते हैं थोड़े पॉइंट्स. देखो जरा इसकी तारीफ में क्या लिखा है. इट इज अ वर्सेटाइल, प्रेडिक्टेबल मीन्स एवरीवेयर वी कैन यूज इट. प्रेडिक्टेबल है, वी कैन प्रेडिक्ट द रिजल्ट ऑन पेपर. वी आर गिविंग द इनपुट, वी आर गेटिंग दिस टाइप ऑफ आउटपुट. वी कैन प्रेडिक्ट, राइट. देन इकोनॉमिक सिस्टम बिल्डिंग ब्लॉक, बहुत ही चीप है ये, आराम से आप अवेलेबल है. हैविंग द स्मॉल साइज, हाई रिलायबिलिटी, reduce cost and low offset voltages and current. At the end we will learn about the offset voltages and currents, so don't think about these words. It is basically a voltage amplifier, voltage control voltage source. Always remember, voltage amplifier means voltage control voltage source. So at the output we have connected the AVVI. So this is a voltage source controlled by the voltage, and that's why it's called voltage control voltage source. Internal power consumption is very low because Ri is very, very high. When the Ri is high, input current is very low, power consumption is very low. Input current is very low. It is originally invented to execute mathematical operation, therefore known as op-amp. It is also referred to as basic linear ICs. तो अगर आपसे इंटरव्यू में पूछता है give me the example of basic linear IC integrated chip, then you can say IC 741 operational amplifier. तो वहां से काफी क्वेश्चंस आ जाएंगे आपके, ठीक है. Then op-amp was first made for performing mathematical operation of differential signals. It is basic linear IC. Easily we can apply the superposition theorem. It is a direct coupled amplifier. Therefore, it can amplify all the frequency signal, including the DC. It can amplify the DC signal. Direct coupled amplifier. This is about all the diagrams and so on. ये देखो पूरा बना हुआ है मल्टी स्टेजिंग एंड सो ऑन. अब फाइनली why the negative feedback is required? Because open circuit operational amplifier has no use, guys. Open circuit operational amplifier has no use. Then it is a direct coupled high gain amplifier. It is a direct coupled high gain amplifier. Open loop gain is very, very high. Open loop gain is very, very high. What is the gain? 10 to the power 6. But what about the bandwidth? Only 1 hertz. Negligible. Right? No use, because bandwidth is very low, then it is unstable actually. It is unstable. For stability, bandwidth should be very, very high. And that's why what we are doing, just to make it stable, we are giving the negative feedback. Because of the negative feedback, gain will reduce, bandwidth will increase. So that's why we are designing the amplifiers and different circuits by providing the negative feedback. By providing the negative feedback, guys. That is the case. If the gain is 10, the bandwidth is 10 to the power 5. Now, very high. Therefore, frequency stability is less. And to compensate this, negative feedback is added to reduce the gain and to increase the bandwidth. Bandwidth बढ़ाना जरूरी है. अरे क्यों नाम है मेरे को भी नहीं पता, आपको पता है क्या? मुझे वाकई नहीं मालूम. Why it is called IC 741? अरे वैसे ये क्वेश्चन था, why 555 टाइमर is called 555? रख दिए नाम. कई बार वो उससे रिलेवेंट होता है कि कंपोनेंट क्यों यूज किया.
555 में सर 5 के का 3 रजिस्टर लगा होता है ना सर.
I am talking about the why it is called IC 741. 555 का तो मुझे भी पता है.
1 आउटपुट होता है, 3 इनपुट पिन होते हैं और 751 मतलब टोटल ऐसे करके कुछ है सर, अभी भूल रहे हैं. जैसे इन्वर्टिंग नॉन इन्वर्टिंग और एक इनपुट.
नो देयर शुड बी नो कंफ्यूजन. ओके बताएंगे बाद में, अभी स्टॉप करो. बताएंगे कंफ्यूज हो जाएंगे नहीं तो लोग. मैक्सिमम पावर सप्लाई इज प्लस माइनस 15 वोल्ट. यस, मतलब मैक्सिमम पावर सप्लाई नॉर्मली वी आर यूजिंग इन केस ऑफ दैट. 555 टाइमर को 555 बोलो चाहे जो बोल लो, तो सब हो गया, पहले इनिशियली यूज हुआ था. नाउ इज इट क्लियर? तो बैंडविड्थ को इंक्रीज कर देता है नेगेटिव फीडबैक. रिमेंबर द गेन बैंडविड्थ प्रोडक्ट इज हाई फॉर ओपन लूप. Popularly used op-amp is IC 741 and it is maximum power supply is what? Plus minus 15 volt. Plus minus 15 volt. This is the IC, guys. This is a 8-pin IC actually. There are different terms, so we will use this 1, 2, 3, 4, 5, 6, 7, 1. This is IC 741. Okay. So, this is the negative supply. That is the positive supply, and right, and this is the offset null and so on. Okay, not required actually. The symbol is different. This is basically a voltage amplifier. Remember, this is more important. Now, what are the properties? Watch this. Characteristics of the operational amplifier. पूरा बता दिया हूँ. Ideal and what is the practical condition? Voltage gain you want infinite, but practically we are getting the 10 to the power 6, because when we are going to make it what infinite, the delay will also become infinite, not possible. Input resistance should be infinite, but actually we are getting 1 mega ohm, very high, by using the emitter coupled differential amplifier. Output resistance ideally it should be 0, but practically we are getting 10 to 100 ohm by using the common collector configuration at the output. We want gain bandwidth product infinite, but practically we are getting 10 to the power 6 hertz. Gain is gain into bandwidth to 10 to the power 6 hertz with the help of multi-staging. Bandwidth we want infinite, but actually we are getting the maximum 10 to the power 6 hertz. When with the help of negative feedback we are reducing the gain up to what 1. इतना नेगेटिव फीडबैक लगाओ कि गेन 1 हो जाए तो बैंडविड्थ मैक्सिमम आती है. ठीक है, अनमोल ने हर बार सही जवाब दिया इसका, क्योंकि लोवेस्ट गेन किसी भी एम्पलीफायर का होगा 1. CMRR बाद में पढ़ेंगे, दैट इज कॉल्ड कॉमन मोड रिजेक्शन रेशियो, और स्लीव रेट वो भी बाद में पढ़ेंगे, दैट इज कॉल्ड व्हाट, मैक्सिमम रेट ऑफ चेंज ऑफ आउटपुट वोल्टेज. तो दिस इज द 80 वोल्ट पर माइक्रो सेकेंड. दिस इज द यूनिट ऑफ द स्लीव रेट. व्हाट इज द स्लीव रेट, वो जैसे जैसे सेक्शन आएगा वैसे वैसे पढ़ेंगे हम लोग, है ना. राइट, तो अब देखते हैं. तो मैक्सिमम सप्लाई 15 वोल्ट और उससे कम भी हो सकता है. बताइए इसका आंसर बताओ भाई. An ideal op-amp is an ideal operational amplifier is an ideal. क्या होता है एक ऑपरेशनल एम्पलीफायर?
डी ऑप्शन.
बोलो मत, लिखो. यार ये 3 आवर्स की क्लास है 2 आवर्स? इज इट ऑफ 3 आवर्स और 2 आवर्स? ये तो मेरे में 3 आवर्स दिखा रहा है, 10 to 1. मुझे तो आज कहीं जाना है. वन मिनट.
दो घंटे की है सर.
तो भाई साहब क्या हुआ? बी है आंसर. वोल्टेज कंट्रोल वोल्टेज सोर्स. बेसिकली इट इज अ वोल्टेज एम्पलीफायर. At the output we are having the AVVI, that is nothing but voltage control voltage source. Basically, operational amplifier is a voltage amplifier. Then, बताओ भाई property क्या है? The ideal op-amp has the following characteristics. Which one is correct? Ideal operational amplifier has the following characteristics. Ri infinite, A infinite, R not 0. Ri 0, A infinite, R not 0. हाँ याद रखना है, इनपुट रेजिस्टेंस शुड बी इनफाइनाइट, gain should be infinite, output resistance should be equal to 0. Output resistance should be equal to what? 0. Right. Then अरे 3 नंबर से तो आउटपुट लेते हैं, तो रुक जाओ, पहले सही इंफॉर्मेशन कलेक्ट करेंगे. राइट. तो दिस इज द ऑपरेशनल एम्पलीफायर. तो ये क्वेश्चन इंपॉर्टेंट है. The first dominant pole encountered in the frequency response of a compensated op-amp is approximately at. This is a theoretical question. First dominant pole, what is encountered here? 1 minute. तो मैंने क्वेरीज की थी तो उसका जवाब आ गया क्या? Now what is, why this is the last question? 5 hertz. This is the answer is what? 5 hertz. Because actually क्या है, this is the called a compensation. Compensation means what? When we are doing the multi-staging ना, when we are doing the multi-staging, तो in case of IC 741, so when we are connecting the multi-staging to increase the gain bandwidth product, what will happen? The gain will increase, but the bandwidth will reduce. And for IC74, the gain bandwidth product is 10 to the power 6 hertz. No problem. So because of this multi-staging, gain increases, and for IC741, the gain is 2 into 10 to the power 5. This is the gain. So what is the bandwidth? Bandwidth is only 5 hertz. Bandwidth is only 5 hertz. So when this 5 hertz is multiplied with the 2 into 10 to the power 5, the gain bandwidth product 2 into 10 to the power 5 gain into 5, you will get the answer 10 to the power 6 hertz. So in why we are getting this much less bandwidth? Why? Because of the multi-staging. So this is the compensation. And first dominant pole, we are using the word from the control system. So we are having the multiple poles, but which one is more effective? Dominant pole, which is near to imaginary axis. So when the which is near to imaginary axis, we are having the number of poles. One poles are far away from the imaginary axis, but it is the near to the imaginary axis, and that's why it is the dominant pole. So we are getting the 5 hertz. It is just like a low pass filter. Watch this. This is a low pass filter. After that, the gain will suddenly fall. And this is because of what? Internal compensation. This is because of the multi-staging. So what is given? The first dominant pole encountered in the frequency response of compensated op-amp is approximately at 5 hertz. It is not the 10 kilohertz, 100 megahertz, 1 megahertz. This is the 5 hertz. So this is a theoretical question actually. This is the theoretical question. can we also define like the difference between the two input voltage to produce? 1 minute, what you want to say, Archita? Can we also define like this difference between the two input voltage to produce the single output for the op amp? That is the differential amplifier. That is the differential amplifier. Don't worry about that. Okay, वो तो differential amplifier की definition है. कल हम लोग डिस्कस करेंगे हर्षिता उसको, ठीक है? कि हम लोग we are connecting the input between the two terminals and we are getting the output from the single terminals with respect to ground. तो वो अलग चीज है. अब तो कल उसका पूरा op amp का यूज आएगा. 1 minute. Tomorrow I am going to discuss what operational amplifier and so on, inverting, non-inverting. Okay. 1 minute. Okay. आज के लिए इतना ही है भाई. असाइनमेंट्स वगैरह कल देखेंगे. अब आज ये असाइनमेंट एक ही आपका. क्या असाइनमेंट है? रिवाइज कर लो. 4 घंटे क्लास हो गई आज. Everyone please revise the BJT from EDC and revise what? Analog first lecture. Go through the syllabus thoroughly. Get the confidence. Yes, it is important subject. जब आपको एक कॉन्फिडेंस आएगा, इंटरव्यू के लिए इंपॉर्टेंट है, सबके लिए आप अपने शॉर्ट नोट्स बना लो आज के. फिर कल से आएंगे न्यूमेरिकल्स. पूरा एनालॉग पे न्यूमेरिकल्स, बीजेटी पे भी आ जाएगा. ओके देन, थैंक यू वेरी मच फॉर अटेंडिंग द सेशन गाइस. बोलो.
कनौडिया के बुक में सर एक क्वेश्चन था और डायोड का, उसमें सर इम्पीडेंस निकालना था तो हमने निकाले, बट उसमें ईटा सिलिकॉन पीएन जंक्शन डायोड है. ईटा सर लिया है एक जी कैलकुलेट करने के लिए कंडक्टेंस, और कैपेसिटर कंडक्ट मतलब कैलकुलेट करने के लिए ईटा 2 ले लिया है सर. उसी क्वेश्चन में सेम क्वेश्चन. तो
ईटा, अच्छा, जी कैलकुलेट कंडक्टेंस कैलकुलेट करने के लिए 1 लिया है ईटा.
जी सर.
और क्या कैलकुलेट करने के लिए? कैपेसिटर.
जी सर, डिफ्यूजन कैपेसिटर कैलकुलेट करने के लिए ईटा 2 ले लिया है.
वो तो मिस्टेक हो गई क्योंकि वहां तो टाउ जी लेना है. तो उसने कोई रीजन दिया है क्या?
नहीं सर, हम भेजे सर, कोई प्लेस नहीं ना प्लेटफॉर्म जहां तक कि मतलब क्वेश्चन हम शेयर कर दें तो दिखे आपको.
हाँ, भेज देना.
व्हाट्सएप पर करना पड़ेगा. ठीक है.
हाँ, व्हाट्सएप में कर देना. क्वेश्चन देख लेंगे. हो सकता है कोई दूसरा लॉजिक हो, पहले क्वेश्चन भेजो, ठीक है?
हाँ.
और या इट मे पॉसिबल दैट प्रिंटिंग मिस्टेक है.
हाँ, डाटा बहुत कम दिया है ना.
कोई बात नहीं, उसको भेज दो. वी विल चेक.
ठीक है सर. ठीक है.
अब देखो ना, डिफ्यूजन कैपेसिटेंस पे आपको क्वेश्चन दिख गया. मतलब नॉर्मली क्या करते हैं, उस टॉपिक कोई छेड़ नहीं रहा है, जबकि हमको पता होना चाहिए. डिफ्यूजन, ट्रांजिशन, सब कुछ पता होना चाहिए.
जी सर.
ठीक. लेकिन पहले मैं आपको बता दूं, एवरीवन, आपने बोला कनोडिया वगैरह ये जो है ना, तब बनाना जब आपका पहले प्रीवियस ईयर क्वेश्चन सॉल्व हो जाए. आर यू गेटिंग माय पॉइंट एवरीवन? प्रीवियस ईयर क्वेश्चन इलेक्ट्रिकल, प्रीवियस ईयर क्वेश्चन इलेक्ट्रॉनिक्स, प्रीवियस ईयर क्वेश्चन इंस्ट्रूमेंटेशन ब्रांच. 3 ब्रांच में एनालॉग है. इंस्ट्रूमेंटेशन ब्रांच, इलेक्ट्रॉनिक्स ब्रांच, इलेक्ट्रिकल ब्रांच. और उसके बाद और करना है तो इंजीनियरिंग सर्विसेज का भी पेपर है. लेकिन ये 3 ब्रांच, उसके बाद आप कोई ना बुक वगैरह में बहुत जाना नहीं, तो बहुत ज्यादा टाइम कंज्यूम करेगा और ऐसा एकदम आता नहीं. और क्वेश्चन कहां से आ रहा है आपको बता दूं, वो सेड्रन स्मिथ के क्वेश्चन आ जाते हैं. ठीक. दूसरा, मेरे ऊपर आप भरोसा करो कि सिलेबस अच्छे से कवर करेंगे ना कि आपसे क्वेश्चन बनेगा. हाँ, अगर आपका सब कवर हो गया है तो फिर आप बनाओ, नो प्रॉब्लम. मुझे कोई प्रॉब्लम नहीं है. अच्छी कमांड होनी चाहिए.
सर आप जो पढ़ा रहे हैं सर, बिल्कुल अभी के रिसेंट में जो सिलेबस आता है वैसे ही पढ़ा रहे हैं.
आ रहा है ना वैसे ही?
जी सर.
ईडीसी भी वैसे ही चल रहा है. बस ठीक है फिर. ओके देन, थैंक यू वेरी मच फॉर अटेंडिंग द सेशन गाइस. थकिएगा मत, अच्छे से रहिएगा. कल पूरे एनर्जी के साथ मुझे वापस दिखाई दोगे आप लोग. ओके देन, थैंक यू. अरे यार, ये पीडीएफ का बड़ा चक्कर है. रुक जाओ भाई, अभी बोलता हूँ. तुरंत बोल रहा है ये पीडीएफ अपलोड करता है एंड आई एम आस्किंग देम टू अपलोड द पीडीएफ. ओके, अभी सेट करता हूँ, रुक जाओ. ओके देन, थैंक यू.